We're dealing with areas. We are still under measuration. We're dealing with areas of triangles. Triangles are three-sided shapes. Triangles are three-sided shapes. There are four main types of triangle. We have the right-angled triangle. Right-angled triangle. We have isosceles triangle. Isosceles triangle. We have the equilateral. Equilateral. This is terra. Lateral. And then finally we have scalene. We have scalene triangle. Now each of these triangles have their own unique properties, and the unique properties will help you to determine or to know how to deal with them when you are faced with them in your exams or when you meet with them in your day-to-day working with mathematics. Let me give you the shapes so that when you see them, you know the type of triangles you're dealing with. The first one is usually of this format. How you recognize a right angle triangle is this small shape at the edge or at the base of the triangle. Now this triangle is there because of the right angle. Right angle, the value of a right angle is 90 degrees. The value of a right angle is 90 degrees. The value of a right angle is 90 degrees. Again, the Pythagoras theorem is only applicable to right-angled triangle. We've already said this. The Pythagoras theorem is only applicable to this. Again, the formula for calculating the area of a triangle, known as half base times height, again is only applicable to this, because this is only the type of triangle that the base is specified, the height is also specified, and usually this is the height. Again, the second one is isosceles. How you'll be able to know an isosceles triangle? Your knowledge of an isosceles triangle will be handy when we get to geometry. One of the basic properties of an isosceles triangle is that base angles are equal. Base angles are equal. Base angles are equal. Opposite sides are also equal. Opposite sides are equal. Opposite sides are equal. Again, equilateral triangle. All the sides are equal. All the angles are also equal. It can also be divided into two equal triangles. Like in isosceles, equilateral is a little bit different. For an equilateral triangle, it looks like this. All the sides are equal. All the angles are equal. And each is 60 degrees. All the angles are equal, all the sides are equal for equilateral. Again, for scalene triangle, none of the sides are equal, none of the angles are equal. This type of triangle the last type of triangle is what is referred to as the scalene triangle. The scalene triangle. The scalene triangle, none of the sides are equal. None of the sides are equal. Usually, a scalene triangle looks like this. None of the sides are equal. Again, none of the angles are equal. None of the angles are equal. None of the sides are equal. And one of the good parts of this kind of triangle is the cosine and the sine rule are well suited for this type of triangle. The cosine and the sine rule are well suited for scaling triangle because none of the sides are equal, none of the angles are equal. Alright? Now let's move on to the area. How do we calculate the area of the triangle? In my little quest, I discovered that we can use three types. We can use three types of formulae to determine the area of a triangle. Number one, the area of a triangle can be calculated by half base times height. Half base times height. Again, you can use half AB sine theta. And then lastly, what we call the Euros formula. The Euros formula can be used to determine the formula or the area of a triangle. In this case, this S is equal to half AB plus C. Now look at this. When you are given a triangle of this format, in which case the height is specified and also the base is specified. Let's say the height is specified as H and the base is specified as M. If you are going to use the area of this first formula to calculate the area of a triangle, then what you're going to get will be half 1/2 times M times the height. That will give you the area of the triangle. Again, if you are given another type of triangle in which case the height and the base is not specified, let's say for instance triangle ABC, in which case any of the angles of this triangle have been presented to you. Let's say for instance you have angle 30 here, and this side has been provided as 3. This side again has been provided as 6 centimeter, 3 centimeter. The second formula gives you the opportunity to determine the area of the triangle, because in this case, if you wanted to use the first formula, it will work, because in this situation, the height of the triangle is unknown. So you apply or you deploy the formula, the second formula for determining the area of a triangle, in which case, concerning this situation, you have 1/2 times 3/1 times 6/1 times sine 30. I need to let you know that if these two values are not binding the angle that is given, then you cannot apply this second formula. In which case, let us imagine that the side that were given to you were 3 centimeter and let's say 4 centimeter on this side. It is not possible for you to use it. The two sides that must be provided must be at the adjacent side, must be the boundary of the angle. In which case, this side must be known, this side must be known. Otherwise, the angle that must be given to you must be somewhere around here. Let's say this one is 40 degrees. Then you can apply this second formula. In which case, these two sides are known. And again, if it is this side and this side that is known, then this angle must be given to you. Otherwise, you must use the sine rule to determine either the unknown angle or the unknown side or the unknown angle, as the case may be. So that is what we have concerning these two types of formula: half base times height, or half AB sine theta. Again, assuming what we have was what was given to us, I alter those values so that you will understand that situations like that can happen, and you must know which one to apply per time. In this case, 2 here will go in 2, 1, 2 will go in 6, 3 times. So if you multiply 3 by 3, you will have 9 times sine 30. If you use your 4-figure table, or you use your calculator to determine sine 30, what you're going to get is 0.5. Then if you multiply 0.5 by 9, again, what you're going to get is 4.5 centimeter squared. So that is using the second formula to determine the area of a triangle. The simplest format, of course, will be this type, in which case a right angle triangle is presented to you and then you manipulate it, having known the height or the base. Again, the kind of situation may present itself in which a right angle triangle is presented to you and one of these sides is missing. And like I've already shared with us the knowledge about Pythagoras theorem, what you then use is use the Pythagoras theorem to determine the unknown side. And as such, you can determine the height or the base. And that gives you the privilege to use the first formula. And then let's look at the third formula. The third formula usually is when you are dealing with a scaling triangle. When you are dealing with a scaling triangle, in which case all the sides are given. All the sides are given, and it is not an isosceles triangle, it's not an equilateral triangle, it's not even a right angle triangle. It's the type of triangle in which none of the sides are equal, none of the angles are equal. When you are presented with that kind of a situation, the third formula comes into play. And I'm going to demonstrate it to us now so that we can know when we are faced with similar situations, we can know how to address such questions. Look at this. If you encounter this question in your exam, PQR, and you have been given 7, 5, 4. And you are asked to find the area. Again, if you look at the two ones, I'm too sure you probably, if you are necessary, you should be familiar with these two by now. But this one is one I'm not too sure if you've seen before. But whatever be the case, these two formulas will not work there, except you first of all determine using the cosine rule to know the angles inside. But again, that will take your time. If this kind of question comes in your UTME, where you are required to use 45 seconds on one question. So what you do is you quickly use this formula to determine the area of a triangle, in which case none of the sides are equal. And of course, I have already given us the clue to determine S. S is half the sum of all the angles. S is the sum when you add all the angles together and then you divide by 2. Let's quickly look at this. So if and like I already shared with us, the small side, the side facing the angle Q is known as small q, the side facing angle R, small r, the side facing angle P is known as small p. So you can then say Q equals to 7, comma, R equals to 5, and then P equals to 4. So our S will be half into Q plus R plus P, which gives us 1 over 2 into bracket 7 plus 5 plus 4. And then eventually you have 16 over 2. 9. 7 plus 5 is 12. 12 plus 4 is 16. Then you have 8. So then you can now apply this formula. This is known as Hero's formula. Hero's formula. Please do not forget, in case this kind of triangle comes up. Then you now use this formula today. So you have A equals to the square root sign. Your 8 is outside. Then you have 8 minus 7. You close the bracket. Second one, 8 minus 5. Then the third one, 8 minus 4. Close the bracket. Then you again introduce the square root sign. You have 8 times 8 minus 7 is 1. 8 minus 5 is 3. 8 minus 4 is 4. If you multiply all this out, you probably get 8 times 12 again, which is 96. 8 times 12 is... Alright, if you use your calculator or you use your 4-figure table, what I'm sure you're going to determine, if you take the square root of 96, is 9.8. So these are the 3 different ways you can determine the area of a triangle. You either use half base times height, use half AB sin theta, or you use the Hero's formula, which is what we have just demonstrated there. Let's quickly move to quadrilateral.